All right, welcome back, everybody, to part 2. Everybody say hi again. Those of you that said hi again, I appreciate you for following directions because you did a nice job. Ben's Chocolate Shop recorded a total number of yearly sales from 1991 through 1996. The manager placed this data on a graph shown. What was the overall change in sales from 92 to 94? So I would underline those on your actual test. Go into your data table, go to 1992 and go all the way up till you get to that point right there. And go over to 1994 and go all the way up until you get to that point right here. I don't care about any other piece of data. But what I do want to look at is look at where the data is in 92 and look at where it is in 94. And tell me, is that data in 1994 higher or lower than it was in 1992? Megan, it is lower. So are the sales increasing or decreasing? Decreasing. So one of my choices has to be either A or B. So I'm going to go ahead and eliminate both of those two. That's the first thing you want to do. It's the easiest thing you can do. Eliminate wrong answers. Now, I want to follow this data point. Oh, nice straight line. Over there, which is about 45,000. And I follow this data point all the way over here, which is about 35,000. And if I want to find how much change there was, what was the difference between those two? Am I going to add or subtract? Matthew. I am going to subtract it. Matthew, what is 45 minus 35? 10,000. 45,000 minus 35,000 is 10,000. That is the correct answer. Yes, sir. 45 minus 35. I got it. Well, yes, it is. 45 minus 35,000 is 10,000. I know, but we understand. Stop being so specific. All right, here we go. Number 7. The graph shows times for runners in the 50-yard dash. How many runners ran a distance less than 7 seconds? Less than 7 seconds. Do I want any information greater than 7 seconds? No. So, oh, wow, that's really kind of blurry. I believe that takes care of all of this information over here. We're just not even going to include that, which means we want to look only at this data right here. And I apologize for the poorness of my graph. It must have got messed up when it got converted. So this looks like it was 6.8 or 6.7 maybe, 6.6 to 6.9. So that's one we got to include. This group is 5 people. This group is 3 people. This is 1 person. And this is 2 people. We're trying to figure out how many total runners. What do you got to do? Add or subtract? Maya. Add. I got to add. So I'm going to add 5 plus 3, which is how much? 8 plus 1. 9 plus 2. 11 is your correct answer. Well done. Again, like I said, so far so good. Really quick, really easy. Next one, number 8, says look at the stem and leaf plot to the right. How many buildings are at least 30 meters tall? At least 30. At least 30. Could they be 35? Yes, that's at least 30. Could they be 40? Yes, that's at least 40. Okay. Miss Litzler, could they be 22? No, they can't be 22 because we don't want them that small. So I'm going to get rid of everything up here. Just totally going to exit out. It's not part of my data. Now I want to look at how much data do I have. Well, my stems represent my numbers in the tens place. My leaves represent the numbers in the ones place. And I have this number and this number, which is 32, right? And then I have 34, 44, 44. Nothing in the 50s, but I have 1 in the 60s, 68. So I have 1, 2, 3, 4, 5 is my correct choice. Any questions? All right. Nicely done. Let's see where we're at now. Maybe we got one more page. I think we do this whole page too. All right. Emily looked at the line plot graph below and calculated the range to be 17. debate whether Emily's answer is correct or incorrect. So here's the line plot. Emily calculates the range. What does the range mean? What does the range mean? How do we calculate the range, Peyton? That's right. You do the maximum minus the minimum. Okay? And Aiden, what is my maximum? Excellent. The maximum is the largest number with at least one x over it. So my maximum is 27. And Michael Otts, what's my minimum? 14. It's the lowest number with at least one x over it. 14. Who's my smarty pants? Who can subtract for me 27 minus 14? RJ. 13 is the correct answer. So, is the range really 17? No. So, I can't remember her name. Emily. Is Emily right? No, Emily is not right. So, that's the first part of the question. Emily is wrong. Now, the question is, you got to defend why she's not wrong, or why she is wrong. Sorry, why she is wrong. How do we know that she is wrong? Michael. Okay, if she took the highest test score that there was, which is 27, and she subtracted the lowest test score that there was, which is 14, she would have got a range of 13. That's what we did. She calculated and said, hey, it's 17. How do we know that she's right? What did we do? What did we do? Or how do we know that she was wrong? Yeah. What did we do? We calculated the range correctly. We took the maximum and subtracted it from the minimum. Okay? Subtracted it by the minimum. Okay? I don't know exactly what she did. Somehow she got 17. She could have done a couple of things wrong. Michael. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 3, 4, 5, 6, 7, 8, 9, 30, 31. She did not. Because 31 minus 27 is not 17. Okay? So, my point, though, is this, you guys. You have got to be able to tell whether she was right and why. Or more yet, why you are right. Whether she is right or wrong and why. Questions? Yes. Jacob. Yeah, thanks. She took all of the numbers and did what? Ah, okay. Yeah. Can't do that. Can't do that. Oh, I still have two more. All right. Well, we'll stop here. We'll pick up with part 3 because I think I'm running out of time. Part 3 to be continued.